Hello and welcome to this video. I am demonstrating a Starship style spacecraft that I built in Kerbal Space Program. It's fully reusable, has in-orbit refueling, and it attempts to solve some of the problems the same way that the actual Starship does. Specifically, it tries to control its entry by rather than changing the center of pressure with wings like the actual Starship does. I change it by altering the center of gravity by moving fuel back and forth. That's a lot easier than dealing with any sort of servos or robotics to try to make some flaps like the real thing has. First off, I'd like to demonstrate a short little sort of standard once around flight with a return to launch site of the Super Heavy booster, and also demonstrate reentry on the Starship, and then I'll show some other little things that this thing is capable of doing. So thank you for viewing. Alright, so first up, let's look at the overall build of this. You'll notice that I have some air brakes at the top. Those are serving as my front fins, so that I can move the center of pressure up towards the top whenever we are re-entering and needing to move back towards tail down. I've got, of course, solar panels and some other air brakes at the back. Those at the back have a blade of cooling. That's my alternative to having a real heat system. And of course, you've got the Super Heavy booster here. You'll notice there's going to be multiple different types of Super Heavy boosters as I've been playing with the design. Alright, in this first section of the video, I'm doing a return to launch site. I'm watching my fuel. I know that I need about 1,300 units of liquid fuel in order to successfully boost back and land the Super Heavy booster. Given how light the booster is after separation, we can get pretty far up in altitude and get a good amount of speed into the second stage before we have to separate. And here comes separation, 20 kilometers and going almost 1 kilometer per second. So we separated at 1 kilometer per second, and our second stage continues on to orbit. Alright, we'll do a quick circularization burn, and then we'll return back to the Super Heavy booster. The mod I'm using in order to be able to fly both stages is FMRS. You'll see that on the lower right hand side. When I click that, it returns me back to separation, and I can fly from the Super Heavy booster back from separation. And here we go. Alright, now we need to quickly flip around to face back towards land and do our boost back burn. I'm watching on the flight engineer to see what biome we are predicted to impact in. Currently we're showing water, but we're going to be switching over to shore and then grasslands. Once it shows grasslands, I quickly cut the boost, and then I bring it back to shore so that we're not going to land on the rough grasslands. Alright, so we're flipping our booster around. I put in a heading of 92 so that I can make us go a little bit south of the KSC so that we don't land on top of any buildings. You'll notice I just switched off I've left only 3 engines on so that our landing burn can be precise. I found that a 3-engine landing burn is much more precise. It seems like Kerbal Space Program kind of bugs out or something whenever you have too much thrust and are trying to land. Alright, we deploy air brakes. Okay, and now we're just going to fall back to the surface. Okay, we've started our landing procedure. Alright, our landing burn has begun. And touchdown of the Super Heavy booster. Alright, now we're going to be doing our landing burn for the second stage. We're just targeting somewhere in the desert to have a nice, relatively flat area to land. Alright, we're going to re-enter with a 45-degree attitude. That gives us a very distinct windward side and leeward side. We've deployed our air brakes. That's just to make sure that our center of pressure is back towards the engines. And then I move all the fuel out of the center tank into the outer tanks, and then I will move the fuel between the top tank and the bottom tank to maintain a good center of gravity that is roughly where our center of pressure is. So as you watch through this section, you may notice me moving the fuel between the tanks. I'm just looking at the pitch and seeing how hard our stabilization system is having to work in order to maintain the correct pitch. And there we go. Now we have it slightly nose heavy, which is what I prefer. Okay, now we're just going through our re-entry heating, burning off our speed. You can see that it's getting harder to maintain the pitch. Okay, and now we're going to switch to tail first. We're going to move the fuel from the top tank to the bottom tank here in just a moment, and we were going to go from the rear air brakes to the front air brakes. Alright, now that moves our center of pressure towards the cockpit, which makes it much more tail stable in orientation. And you can see we have all of our fuel in the bottom tank. That lowers our center of gravity and makes sure that we have a stable landing, and also that that we aren't going to flop back towards front first. And here comes our landing burn. And touchdown with about 2 kilometers a second of delta V left. Now let's do this without landing at the launch site. Let's go ahead and land downrange so we can keep more of our delta V once we arrive in orbit. Launch is fairly similar at the beginning. We're watching to see where our landing site will be. So we wait until our landing site is predicted to be on that little peninsula there, and then separate. And you can see we're already going about 1,400 meters per second, so we're separating at a notable speed higher. Alright, we circularize into orbit. You can see that our first stage is basically landing at the same time that our second stage enters orbit. Now back to our super heavy booster. We're going to just reorient ourselves to be engines first. Move fuel to the bottom fuel tank, that gets us more stable. You can see that we only have about 500 meters per second of delta V with which to do our landing burn. Once again, we're going for a 3-engine burn on landing. We're going to wait to deploy our air brakes until we are certain of where our landing site is, because otherwise we are wasting energy. It's kind of hard to get all the way over to this peninsula, and so we don't want to waste any fuel burning more than we need to. Beginning of our first stage reentry heating. Okay, deploy our air brakes. You'll see that we get up to 5 Gs of deceleration from deploying the air brakes, up to 6 Gs now. And we start our landing sequence. Still getting great deceleration through the air brakes, saving us a ton of delta V on landing. Okay, start of our landing burn. Deploy our landing legs. And touchdown. Now we just need to keep from tipping over with those tiny landing legs. It's a wobbly booster. But all those engines and fuel at the bottom make it very bottom heavy and keeps our center of gravity low to the ground. Only 85 meters a second of delta V left. And of course we can still return our second stage the same as we did in the first section of the video. Okay, we're done with our reentry heating. You can see it's naturally wanting to go into tail heavy at this point, so we go ahead and swap over tail first. Real world, you'd want to get it a little bit lower to the ground first so that you keep a large cross-sectional area to reduce your terminal velocity to more manageable speeds, and swap to tail first at the last second. But we've got plenty of delta V, and it doesn't really matter too much. Better to just maintain stability in the case of doing it in Kerbal Space Program. Alright, we're preparing to land, and we have 2.9 kilometers a second of delta V before landing. Seems that our fuel was basically the same, but 2.4 kilometers a second at landing, and it looks a lot cooler to land downrange. And there you have it. Alright, so the goal of this video was just to introduce my Starship design. If there's any interest in the next video, I will be taking my cargo version of the Starship, landing it on the moon, and also landing crew on the moon to take advantage of the cargo we land on the moon. You'll also be able to see in-orbit refueling, which is unnecessary for a simple low Kerbal orbit. So let me know if you have any interest in seeing the rest of the videos that I have in mind.